Greetings students, welcome back to another video from iCampSA. Today we're going to be doing mathematics. This is a practice assignment for 2026 and it's from the Limpopo province, and this is done by iCampSA. So without wasting any time, and this practice paper is out of 50 marks. I hope you noticed that. So it covers most of the things from functions, geometry, and yeah, functions, geometry, and let me see what else. Yeah, so basically, yeah, it's mostly functions and geometry. Okay, so for question 1.1, use the diagram below to prove that the opposite sides of a parallelogram are equal. So we need to prove a theorem that says the opposite sides of a parallelogram are equal, as it is already represented by these arrows, which also shows that the opposite sides are parallel. So we are given what we are given there, angle P1 and P2, angle S1 and S2, and angle R and Q. So we have to prove that the opposite sides of a parallelogram are equal. So already we know that line PQ is parallel to line RS. These two are parallel. So once we know that these two lines are parallel, then we can conclude that angle P2 and angle S1 are equal based on what? Based on those are your alternating angles. So we can go ahead and write that. So for 1.1 was saying angle P2 is equal to angle S1, and the reason is alternating angles. And also what other sets of angles are equal? We can see that angle S2 is equal to angle P1 based on that these two lines, line PR and line SQ are parallel. So we are already given on the diagram that these two lines are parallel. So the conclusion that we have made is that angle P1 and angle S2 are equal. So as saying angle P1 is equal to angle S2. Once again, the reason is alternating angles. It's alternating angles at K. And then next, we can see when we consider these two triangles. When we consider these two triangles, which is triangle PRS and triangle PQS, we can see that they share this side, which is side PS. So we can say side PS is equal to side PS. So side PS or length PS is equal to length SP. And the reason is common side. We just say common side. So once we have shown that, and we have already proved that the angles, the equal angles in these two triangles, we have already proved that. So once we have shown that, or once we have stated that side PS is common between these two triangles, let's now look at the two triangles, which is triangle PSR. It's a bit ugly. Triangle PSR, they have a common side and two angles in this triangle are equal. So therefore these two triangles are congruent, which means they are identically the same, or they are perfectly identical. These two triangles are perfectly identical, since we have proven that they are congruent. Therefore, so we can say, therefore, triangle it's PRS is congruent PRS with triangle PQS, based on what? Based on the side and angle. These two triangles are congruent. Therefore, once we have shown that these two triangles are congruent, which simply means that they are perfectly identical, then we can make the conclusion that therefore side PQ, which is opposite with side RS, is those two sides are equal. Therefore, side PQ is equal to side RS, and therefore side RP and side RP is equal to side SQ. So basically, that's how you prove that these two triangles, that the opposite sides of a parallelogram are equal. By using congruency. Okay, and then next for 1.2, we are asked for 1.2, in the diagram below, ABCD is a parallelogram with G is equal to 9x plus 12 degrees and F and angle F. So those are your angles, is equal to 15x minus 24 degrees. So we also calculate the value of x. So we know from our understanding of parallelogram, since we have been told that this is a parallelogram, is that opposite angles of a parallelogram are equal. So we can say angle G is equal to angle F, that is 1.2.1. So angle G is equal to angle F, and the reason is opposite angles of a parallelogram. Okay, so from there we just substitute the values. We know that G is 9x plus 12 degrees is equal to F, which is 15x minus 24 degrees. Then from here we simply solve for x. So we're going to have 15x minus 9x is equal to 12 plus 24 degrees. 12 degrees plus 24 degrees. So 15x minus 9x is going to be 6x, which is equal to 36, and then we divide by 6 on both sides. Therefore, x will be equal to 36 divided by 6 will be equal to 6. X will be equal to 6. Okay, and then from there we are also calculate or to determine the size of E. So in order to determine the size of E, we have to use co-interior angles. We know that co-interior angles are supplementary, or they add up to 180 degrees, because the opposite sides of a parallelogram are parallel, which will make angle E and angle G to be co-interiors, or we can use angle E and angle F, whichever one will still get the same answer. Let's just use angle E and angle G in order to calculate the size of angle E. Then that will be our 1.2.2. 1.2.2. So we are saying angle E plus angle G is equal to 180 degrees, and the reason is co-interior angles of a parallelogram. We can include that. Okay, and then from there we know that angle E is the one that we are looking for, plus angle G is 9x plus 12, 9x plus 12 degrees is equal to 180 degrees. Then angle E, now let's substitute x in place of, let's substitute 6 in place of x, because we know that x is equal to 6. So 9 plus times 6 plus 12 is equal to 180 degrees. And then from there, angle E is equal to 180 degrees. 9 times 6 is going to be 54 plus 12. So minus 54 plus 12, which would be 66. I would like to believe it's going to be 54 plus 12. Yes, this is going to be 66. Therefore, angle E is equal to 180 degrees minus 66 degrees. This will give us 114 degrees. I'm not using calculator, so please double check for me. So I would like to believe that will be 114 degrees. And then from there, let's go to question 2. So question 2, we're told that in the diagram below, N, T, W, and Z are the vertices of a quadrilateral, and T, W, Z, they are the vertices of that quadrilateral. So we're just given a statement basically. Okay, let me do like this, copy. Okay, then where has it gone now? Okay, it's okay. Let's drop, because I wanna drop it so that we can see the statement while we are doing it. Okay, that's okay. So we are already told that N, T, W, and Z are the vertices. As we can see that these are the vertices of this quadrilateral. The statement are referring to this diagram that we have here. So for 2.1, we are asked to determine coordinate M, the coordinates of M, the midpoint of NZ, the midpoint of NZ, which means M will be somewhere here, not exactly on the line, just but halfway of NZ. So we have to use the midpoint theorem in order to calculate, not the midpoint theorem, but it's just the is it the midpoint theorem? No, it's not the midpoint theorem, but we have to use the midpoint formula. Made a mistake. So we're asked to calculate the coordinates of M. So xm is equal to the x of n plus the x of z divided by 2, and the y coordinates of M will be equal to the y of n plus the y of z divided by 2. Now let's plug in the values and solve. So the x of n is -6 plus the x of z is 5 divided by 2. This will be -1/2. And then the y of n is -6 plus the y of z is -3. So divided by 2, -6 minus 3 will be -9/2. Will be -9/2, like 4.5. Okay, so these are basically the coordinates of M. We can write it as such. M is the coordinates of M is -1 and -1/2 and -9/2. Okay, and then from there we are asked to calculate the gradient of the line NT. So we have to use the gradient formula since we have both coordinates of N and T. The coordinates of N and T. So for 2.2, we are asked to calculate the gradient of line NT. So the gradient formula, gradient of line NT is the difference of height yn minus yt over the difference of the run. So xn minus xt. This will be equal to the y of n is -6 minus the y of t is 0 over the x of n is minus 6. The x of n is minus 6. Yes, and the x of t minus 3. Therefore, this will give us minus 6 over minus 9. Therefore, this will give us 6 over 9, which is 2 over 3. 2 over 3. Because negative 6 divided by negative 9 will give us a positive 6 over positive 9, of which is equal to 2 over 3. Okay, and then from there we're asked to prove that NT, that line that I've highlighted there, is perpendicular to TW to this line. So here what happened, they actually made a mistake. There is no way that TW is perpendicular to NT, but we have to use, remember that we have to use the radians, because the product of the radians is equal to -1 if two lines are perpendicular. And here we have no way of calculating the gradient of what, of TW, since we don't have that W coordinate. So instead, here what they were trying to say is that we have to prove that NT is perpendicular to TW, sorry, to TZ. We have to prove that NT is perpendicular to TZ. And in order to do this, I've already mentioned that we have to calculate the gradient of TZ, and then if the product of the gradient of TZ and the gradient of NT is equal to -1, then these two lines are perpendicular. So let's go ahead and do that. We've already calculated the gradient of NT, which we find to be 2 over 3. So the gradient of what, of TZ now, we said is the difference of the height over, so YT minus YZ over the difference of the run, XT minus XZ, is equal to, so the Y of T is 0 minus 3, the Y of Z, over the X of T is 3 minus 5. So we're gonna have 3 minus 5. Okay, so here what are we gonna have? Negative, and the negative, we're gonna have a positive 3 over 3 minus 5 will be a -2, so we're gonna have negative 3 over 2. That would be the gradient of TZ. Okay, so then let's go ahead and calculate MNT multiplied by MTZ, the gradient of NT multiplied by the gradient of TZ, to see if it is equal to -1. So gradient of NT is 2 over 3 minus -3 over 2, and then if you punch this in a calculator, you will indeed get -1. Therefore we can confirm that it's line NT is perpendicular to line TZ, not line TW. Okay, and then next we are told that if NTWZ is a parallelogram, we are asked to calculate or to determine the values of X and Y. So we are now told that NTWZ, this quadrilateral, is actually a parallelogram, meaning this line is parallel to this line, and this side is parallel to this side. And then what we know about a parallelogram is that the diagonals of a parallelogram, they bisect. The diagonals of a parallelogram, they bisect, meaning that the midpoint of NZ will be the same as the midpoint of what, of TW. So we can utilize that information or that understanding in order to calculate the values of xy, which are the coordinates of w, So we've already calculated the midpoint, and we find it to be -1/2 and -9 over, so it's 2.4. We say the midpoint m is -1/2 and -9/2. Double check. Yes, that is that. Okay, then now let's calculate x and y by using the coordinates of the midpoint, the coordinates of w, and the coordinates of t. So we know that the midpoint, which is x of m, is equal to xt plus xw, which is the x that we are looking for, over 2, and then ym, which is the y for the midpoint, is equal to y of t plus y of w, which is the y that we are looking for, divided by 2. And then once we are here, we simply substitute the values. Okay, so the x of m is -1/2 is equal to the x of t is 3 plus the x of w is the x that we are looking for, over 2. Let's solve for x. We multiply by 2 on both sides. We're gonna get a -1 minus 3 is equal to x. Therefore, x is equal to -4. X is equal to -4. Okay, and then from there, let's calculate the y value. So the y of m, which is this one here, the y of m, the y of the midpoint, is -9/2 is equal to the y of t is 0 plus the y that we are looking for, which is the y of w, divided by 2. Okay, and therefore here we're gonna have, we multiply by 2 on both sides, which would give us -9 is equal to y. Therefore y is equal to -9, which makes the coordinates of w, or x and y, to be -4 and 9. So the coordinate of w is -4 and -9. That's how you go about solving that last question, by using the midpoint formula and our understanding of the parallelograms. Okay, next let's go to question 3. Let me drop this for question 3. For question 3 up until here, I don't know why I jumped over. Can also drop here. Okay, then let me put it down. Okay, yeah, I hope it's still visible. Okay, so for question 3, we are dealing with functions. The question of a straight line f has the following coordinates, or the equation. The equation, yes, there's the following equation, has the following coordinates, which is a, -2 and 4, and b, 2 and 0, respectively. For 3.1, we're asked to draw a neat graph of f, indicating the coordinates of a and b on the graph, and label the graph as f. So for 3.1, we are just sketching. So whenever we're sketching, we start by drawing our Cartesian plane. Okay, so and then we calibrate our Cartesian plane. So it's 6, 4, 6. So have to calibrate so that we can have accurate. So I'll use the intervals of 2 instead of 1. So we'll use 2, 4, 6, to -2, -4, -6, 2, 4, 6, and we also need to label our axes. These are y axis and these are the x axis. Okay, here we're gonna have -2, -4, -6, -8. Okay, and then let's plot our coordinate. For a coordinate is the x value is -2, which maps with 4, so -2 would be here and 4 here, therefore our coordinates will be here. And then for b, the x value is 2 and the y value is 0, so it means it should be here on the x-axis. And then once we have drawn our coordinates, or once we have plotted our points, we just join them with our ruler. We join the 2 points that we have just drawn here. Yes, and then we can once again label the coordinate. This is -2 and 4, and then b is 2 and 0, and we also label the graph as f. Okay, and then you are done at that point. And then next we'll also determine the equation of f. So we know that f is a straight line, so we have to determine the straight line equation of f. So the general form or general formula for the straight line equation is y is equal to mx plus c, with m being the gradient and c being the y-intercept. Okay, so we need the gradient in order to calculate the equation of f, or in order to determine the equation of f. So let's quickly calculate the gradient. M is equal to, it's basically y2 minus y1 over x2 minus x1, but here you know it's gonna be ya minus yb, or yb minus ya, xb minus xa. So just make sure that those two, they correspond. If you started with the y value of b on the numerator, also start with the x value of b on the denominator. Okay, so let's go ahead and do that. Calculate the gradient. So by the way that our line is going from the second quadrant to the fourth quadrant, we can see that the gradient is going to be negative. But let's quickly calculate the gradient. Y2, let's use the y of b is 0 minus the y of a is 4 over the x value of b is 2 minus the x value of a, which is minus 2. Therefore our gradient is going to be -4 divided by 2 minus -2 is going to be 4. So it's -4 basically divided by 4, which is -1. That is our gradient. So we're going to have y minus x plus c. Now we need to determine the value of c. We can use any coordinates between a or b, since they both lie on the straight line. So let's quickly use b. B y0 is equal to negative x, of which would be -2, plus c. Therefore c is equal to 2. C is equal to 2. Okay, therefore we have now calculated our equation, and it's going to be y is equal to -x plus 2. -x plus 2. Okay, so that is the equation of f. That is the equation of f. Okay, and then for 3.3, we're told that a straight line G is perpendicular to f, to that line f, and it passes through the point A. So it's gonna be like this. That will be your G. It's perpendicular to f, and it's gonna pass through the point A, as I've just drawn here. So we also calculate the x-intercept of G. So what we need to do in order to calculate the x-intercept of G is to actually start by calculating the equation of G. The equation of G, and since we know that these two lines are perpendicular, we can find the gradient of G, and we have the coordinates of A there. So let's go ahead and do that. So this will be 3.3. 3.3, we know that's 4 perpendicular line. So MF multiplied by MG, the gradient will be negative. The products of the gradients will be equal to -1. So gradient of f mf. The gradient of f is what we calculated it, and we find it was -1 times the gradient of g is equal to -1, the one we're looking for. Basically, we divide by -1 on both sides, and the gradient of g will come up to be just the +1. And then we come here to a straight line equation. Y is equal to mx plus c. Let's find the value of c. And we know that the line of g passes through the point A, which is -2 and 4. We can use that is equal to the gradient is 1 times the x is -2 plus c. Therefore, c is equal to 6. C is equal to 6, of which would make the equation of g to be y is equal to x plus 6. And then once we are here, for the x-intercept that we are looking for the x-intercept, y is equal to 0. We need to equate y to 0. So the x-intercept we have is going to be 0 is equal to x plus c. Therefore, the x-intercept is x is equal to -6. X is equal to -6. That will be the x-intercept. Okay, so remind that the graph or the line that I've drawn passes through -4. Remember that our Cartesian plane is not drawn to scale, and in fact, let me erase it because it's not part of what was asked on 3.1. It was just for demonstration purposes. Okay, so the straight line G. Okay, so yeah, we are done with question 3. Let's go ahead and do question 4. So question 4, we're given a statement in the diagram below. 0 is the origin. Okay, P is the line given by the equation P at x is equal to mx plus c. So we already know that T is a straight line equation, and all the points A, B, C, and D lies on this line, A, B, C, and D. Okay, K is the graph of a parabola with the equation kx is equal to ax squared. Then we can already tell that the parabola will have no root, it only has one root, yeah, which is that 0, because we have been told that it passes through, just by looking at it, we can tell that it only has one root. And another thing, that the value of a, since it is facing downward, it's gonna be negative. Okay, and then D and B lie on both K and P, so lie on both the straight line and the parabola, and at the intersections of the both graphs. Okay, so from the word go, we are asked to determine the range of K. So we have to determine all the y values for which the parabola or the K function exists. Okay, maybe let me try to drop this one first. Maybe it will give us some space. And I don't know, I decided to jump up. It's out of 7. Let me bring it down. Let's see. Okay, yeah. So for 4.1, we are asked to determine the range of K. So for the range of K, determine the range of K. So we can see that our graph is facing downward, but it goes from 0 to -infinity. So we say y is the element of 0 to -infinity. These are all the values for which our function exists. Okay, and then next we also calculate the domain of P. Determine the domain of P. Okay, so I ended up dropping it even higher, but yeah, P is that straight line equation. So the domain of P for 4.2, we can see that our function exists for all values, for all x values. So x is the element from negative infinity to positive infinity. That would be the domain of P. Okay, given the gradient of AD, is 1, determine the equation of AD. So we already, or in the form of P at x is equal to x plus c, we are to determine the equation of AD, basically the equation of the straight line. That is what we are asked to determine here. And we have the coordinates of A there, which is 6 and 0. So therefore we can calculate, and we are given the gradient, we can determine the equation of AD. This would be our 4.3. So for 4.3, m is given to be 1. Therefore we have to solve for c. P at x is equal to mx plus c. We know that this line passes through A, and the coordinates of A is 6 and 0. So P at 6 is 0 is equal to m is 1 times x, which is 6, plus c. Therefore c is equal to negative 6. Therefore P at x is equal to x minus 6. That's the equation of the line AD. Okay, and then next we are also to determine the equation of K in the form of K. X is equal to ax squared if B, this coordinate here, is equidistant from A to C. If B is equidistant from A to C. So in other words, what they are just telling us here is that B is the midpoint from A to C. So we can calculate the coordinates of B and use the coordinates of D, or the coordinates of B, to find the equation of K. But first we need to calculate the coordinates of B, of which is the midpoint. So 4.4. Let me just start by saying B is the midpoint. We are given that, since we are told that B is equidistant from A to C. B is midpoint. So we have to use the midpoint formula. Let me write for you. Remember that midpoint of AC. Let me just say that the coordinates of A is 0, 6 and 0, and the coordinates of C in 0 and minus 6. 0 and minus 6. So let's calculate the coordinates of B. XB, midpoint formula, it's gonna be XA, which is 6 plus 0 divided by 2, and then YB is gonna be negative 6 plus 0 divided by 2. Therefore XB is essentially 3, and YB is negative 3. Yes, it's negative 3. Those are the coordinates of B. It's 3 and negative 3. Okay, and then next, since we have the coordinates of B now, and B lies on the parabola or the graph of K, we can solve for A. So let's take this as it is. So K at x is equal to ax squared, that is K at x. So let's substitute the values of y and x, and remember that K at x means y in other ways. So this is going to be negative 3 is equal to a times x, which is 3 squared. 3 squared is equal to what? Is equal to 9. Therefore we divide by 9 on both sides. 3 squared divided by 9 is 1. Therefore, a is equal to negative 3 over 9, which is equal to negative 1 over 3. Negative 1 over 3. Therefore, k at x is what? K at x is equal to negative 1 over 3 x squared. That is the equation of k, of the parabola. That is the equation of k. Okay, and then next we are asked to calculate the coordinates of D. And D, we are told that D and B are the intersections, meaning that our functions are equal on those 2 points, D and B. They would give us the same values. So at the intersections, when we are asked to calculate or find the coordinates at the intersections, this is what is 4.5. Since we know that D is an intersection, what do? We equate our equations. So k at x is equal to P at x at what? Let me just say at intersection. At intersection. Okay, and then what is k at x? K at x is negative 1 over 3 x squared is equal to P at x. We have already calculated P at x is x minus 6 is x minus 6, and then from here we solve for x. So we're gonna be left with negative x squared here multiplied by 3 at both sides. Then we're gonna have 3x minus 6 times 3 will be 18, and then let's move everything to one side. Minus x squared minus 3x plus 18 is equal to 0. Is equal to 0. Let's divide everything by negative 1. We'll be having x squared plus 3x minus 18. Minus 18 is equal to 0. Let's factorize. We're gonna have x and x here. Factors of 18, that's when we add or subtract, give us 3 will be 6 and 3, and we are looking for a positive 3, therefore we put a positive 6, of which will make x to be equal to 3 or x is equal to negative 6. So just by observation of our graph, we can see that x is equal to 3, and we've already actually found that the x which is equal to 3 is for b, because b is 3 and negative 3. So therefore the coordinates of D, or the x coordinates of D, will go with negative 6. Negative 6 is also on to the left of the y-axis. So D is negative 6. We just have to calculate the y-axis. So D, we go with, the y coordinate. So we can use either a straight line or the parabola to find the y coordinates. We still find the same thing. Let's use the straight line. Y is equal to x minus 6. X minus 6. Therefore y is equal to minus 6 minus 6, of which is negative 12. Therefore the coordinates of D are negative 6 and negative 12. So always when you are asked to find the coordinates of a point where two graphs intersect, what do? We just simply equate the equations of those two functions, and that's how and then you solve for x, and then you take the x value that you're gonna find, you substitute it on either of the equation to find the corresponding y value. Okay, and then what kind of a triangle ACO? Triangle ACO. What kind of a triangle ACO according to the length of the side? Oh, okay, so we can see that side OC is what is 0 minus 6 will be 6 units, and side OA will be 6 units also. Therefore this is an isosceles triangle, but it's also a right angle triangle. So also a right angle, but according to the length it's an isosceles triangle. So for 4.6, this is an isosceles isosceles. My spelling of isosceles. Isosceles, yeah, I think it's correct. Isosceles triangle. It's an isosceles triangle because two sides are equal. Because two sides are equal in length, which is side OA and side OC. OA is equal to OC. That's equal to OC. And then next, without any calculation, give the value of angle C, this angle here. So we've already identified that this is an isosceles triangle. We know that the angles opposite equal sides are equal. So we know that angle C and angle A will be equal since they're opposite equal sides. And then we know that the angle there between the x-axis is what? X and the y-axis, angle O is what? Is 90 degrees. Therefore, that will make angle C to be equal to 45 degrees. 45 degrees. That will make angle C to be equal to 45 degrees. Angles opposite equal sides. This is equal. So angle C is equal to 45 degrees. Since we have already identified that was the isosceles triangle, that will make angle C to be 45 degrees. Okay, and this marks the end of this video. I hope you learned something. And please do share with your classmate and share with a friend. I'll see you on the next lesson, and good luck with your exam. Good luck with your studying.